Good news is I'm going to give you the script below my YouTube video that you can paste into OpenSCAD, and you can run this and you can have a pattern in just a couple minutes that is perfectly customizable to your particular CNC. OpenSCAD is a strange program that reminds me a lot on YouTube, and you see an incredible violinist that goes in disguise to some subway station with their Stradivarius and people don't even know, and they play a song and people walk by and they just completely ignore them. And yet, you know, days before they played in Carnegie Hall and people were paying hundreds and hundreds of dollars per ticket, yet when it's right in front of them, they walk by. OpenSCAD is just like that. It is an incredibly powerful program that if a manufacturer was selling it, people would pay a lot of money for, but because it's open source, it doesn't have all the people trying to sell it to you, so a lot of people just don't really know how powerful this really is. In many ways, I like this software better than VCarve Pro, which I also own, which is a good software, and it does some unique things as well, but this is completely free, whereas VCarve Pro, you're talking quite a bit of investment. I think it's like the perfect spot for the people building a CNC. Let me tell you why. It's not just to model something. We can take what we model and we can easily export an SVG, which with just a household printer, you can print it out. And that is just huge because then you have your pattern. So instead of trying to do it on an overhead sheet like I showed you in the last video, this is allowing you to do it. And the other thing is it's fully customizable. OpenSCAD has a way of adjusting things parametrically, which VCarve and a lot of the other software packages that you might buy in CAD don't have. That means it's a little more work to get set up on the front side, but then you can do an infinite number of varieties, and then you can run this and you can have a pattern in just a couple minutes that is perfectly customizable to your particular CNC. So you can adjust any rail width, any bearing width, any hole sizes, and it's going to make it perfect, and you can print it. If you have a laser cutter, you can cut it with a laser cutter. If you have a CNC or know somebody, they can go mill this thing in a few minutes, very, very exactly, much easier than using a drill press or a hand drill. Not that you can't use a hand drill and just tape your pattern down on it. You can 3D print this as well. So you could generate with minor code adjustments, turn this into a 3D print. You're not gonna find anything else like this on YouTube. You can just copy and paste. One thing I'm always leery of is when people have these programs that you have to download, you're always worried about getting a virus. Well, this is just text that I'm putting below the YouTube video. You just copy the text, you can paste it in yourself right into the OpenSCAD software. Hopefully you installed OpenSCAD CNC, and the first time you use it, you'll probably have to click on this new button, and it should bring up your display. Probably will look something similar to this, might be a little bit different. If you're missing some of these windows, we particularly are looking for this editor, this main display, and this customizer. If something's missing, come over here and click on it. If you went ahead and copied the code that I put in the description section below this video, literally left clicking, dragging, selecting, right clicking to copy to clipboard, and then install OpenSCAD, come in, create a new file, come into the editor window where you see my cursor now, and right click with your mouse button. You can paste in the code, and when you do, you should end up with something that looks similar to this. Now, nothing appeared on the display. That's normal when you first come in and you get the code. It doesn't generate until we tell it to render. So what you have to do is come up here to this button that is located, or hit F6 on your keyboard, left click on it. And when you do, suddenly in this window, if you have it scaled right, you will see something appear in the window. It may be a little bit different color scheme than I have because I've customized it slightly. It is very, very helpful when you're doing this. If you have a mouse that is a manual mouse versus a trackpad, you want one with a scroll wheel because that'll zoom in and out. The left button will allow you to rotate and the right button will allow you to pan. I'm going to go ahead and scroll with my middle mouse button. I'm left clicking and I'm rotating my axes here so I can see what's going on. Here's my x-axis, here's my y-axis, and here's my z going up, because this is actually capable of generating 2D models and 3-dimensional models. We're going to do it in 2 dimensions because we want to be able to print it on a printer or cut it on a laser or maybe use it on our CNC. But you certainly can extrude it and make something that you can 3D print. Go over here to the customizable window. If this isn't clicked on automatic, click it on automatic, and then down click this arrow for parameters. These are the adjustable parameters that are written on the left-hand side that you could manually retype them and regenerate them, but this makes it a whole lot easier. It's because of the way I wrote the code. I'm not going to get into the specifics, but the bottom line is you can use it and you can generate your gantry very, very easily. Come to the bottom parameter and either drag the slider or come over here and hit the up arrow or type the number 1. Now nothing happened, and sometimes you will have to go over here and hit the F6 button, and suddenly this looks a lot more promising. These represent the bearing blocks that would go on the Y rails. This is the nut housing that goes on the ball screw. You can see that they're sized. Those sizes are determined by the parameters. For example, if I wanted to change the width on any one of those bearings, I can come over here and I could drag it or I could adjust it. Right now it's set for a width of 48 millimeters wide. Let's just drag it to the left and see what happens to it. And you see that immediately the model shifted. Now, it may concern you because the screw holes didn't shift with it. We don't want it to shift with it. We want the screw holes defined by the spacing that we individually put in the parameters. Let me stretch this back out and let's change the height of the bearing. Let's make it more. And when we do, you'll see that it adjusted all the way, but the hole spacing stayed the same. That's a good thing. What sets the hole spacing? The answer is the H space X sets it. So right now, the distance from here to here is 35 millimeters. If I want to change it, I can type manually. Let's say I wanted to make that 25.5 millimeters because that's the way the manufacturer made my particular bearing. Hit enter, and it adjusted all of them. Let me do that again, and I will make it more extreme. Let's make it down to like 15. And you can see immediately it changed on all 16 holes all at once. I can drag it back out. I can type in whatever numeric value I want. The same goes for spacing. Now, if you go too far, it's going to go off the edge and you won't see it. So let me change the Y spacing. I'll scoot it down a little bit. You can see it allows it. And you can get very exact numeric values in here. If you get something strange that you want to reset, you've lost where these are, just hit the reset button at the top and it will revert back. Now, when you get these all dialed in, if you want to save all the presets that you've done, because they're going to be one value here, but a different value over here, you can do that. What other things do we need to be able to adjust? Well, let's go change that flag back to 1 and regenerate this so that we have all the things on the screen at the same time. It would be nice to be able to address this gap that we have between the bearings, and that is determined by the gap Y parameter. So right now, the distance from here to here is 120. Let's go ahead and shift that down, and you can see it adjusted all of them so that they're aligned. I'm going to scoot that back up a little bit. Now, what other things would be nice? Well, maybe the ball screw housing has different dimensions than these do. It's almost certainly going to. I defined it based upon what my manufacturer said inside the program, but you can adjust yours to whatever you may have purchased. So what do we do there? Well, here's the ball housing width parameter. Right here, it's at 52 right now. I could make it bigger. I could make the height bigger. Note the screws didn't change position. Those screws have their own spacing you can define down here. So you can have the adjustment here for the screws or here for the screws. So this is for the ball nut. And if you want to change the diameter of the screw that goes in there, you can drag this up, and you can see that they're getting larger. I hope you understand the value. Now, what about the spacing from here to here? If you watched my last video, I recommended that you had the metal rail and you had your ball screw and you put a spacer of exact width in here, and you made it relative to the bottom metal rail, not this bearing width, but the bottom metal rail. So we would need how far that is and the space gap to get over here to the edge of my ball screw. What is going to be the width of the rail here that this is on? The answer is that is the rail width parameter. Now you're not visually seeing it drawn, but it's there underneath the surface. Now, what about the spacer width? The spacer width is not drawn either, but let me just shift it so you can see what happens. So when I shift this, see how the gap in here was diminished here and here? It's because I'd assume that you use the same size spacer going up and down. And of course, we could have whatever we want, so we can dial in exactly. When you get all done, what good does this do us? Well, we have to be very careful when we change these things that we make sure that we re-render all of this, because if you don't, when you export it, you might get something different. So I'm going to re-export this as an SVG, and I'll just put it right over the example gantry, and let's go see what we get this time. And when you go into example gantry and click on it, there's what we were expecting, something that looks like this. Right click, go to print, but click on the button for landscape, and of course you could drag this into another program. Just make sure that it's not clipping. Watch what happens when I do portrait here. It may scale this down ever so slightly, and that will change the dimensions of everything. So make sure you have space. If you feel like it's crowding your paper in any way, then make sure that you go and change that flag at the bottom of those parameters. And then of course we could print this, and then we could go drill out these holes with the drill press or by hand, or if they were sized correctly, you could laser cut them or put them on your CNC. So I want to leave you with a few tips that you definitely want to hear. Before I do, if you appreciate open source and you appreciate the effort that went into making this and it's helpful to you, I'd really appreciate it if you could hit like. If you haven't subscribed, subscribe, and maybe even leave a comment. If you have any additions that you'd like put in this program, if you leave it in the comments below, I'll try to accommodate it if I can. With that being said, here's some tips that you might find really, really helpful. Tip number 1, don't hesitate to change the hole size to a different hole diameter than what you're physically going to put in your bearings, especially if you're going to hand drill them out. Make it a little pinpoint screw hole, and that way it's easy to put your brad bit on. Tip number 2, don't hesitate to cut out the physical outline of the bearing or the ball nut housing and lay it right directly on top of your rail and check to see whether or not it lines up. If it doesn't, then you can adjust accordingly. Tip number 3, you can definitely linear extrude any of these parts with 3D printing and use them to make a shim if you have different heights between the bearings on your rails and your ball nut housing, which is highly probable. Tip number 4, if you don't have a 3D printer, you can still accomplish that similar sort of thing by cutting out the individual outline of one of these, either the ball nut housing or one of these bearing mounts, gluing it onto a board of the appropriate thickness, and then drilling out your holes manually. You can use that as a shim,